Everybody happy? Relieved? Joyful? Wonderful. I'm so glad to be able to introduce our wonderful speaker this afternoon. I think you're really going to be inspired and enjoy her. And this is Monica Block. And Monica is one of our own 2008 graduate. So I'm going to read you a little bit about her and then let her share some lessons learned from her journey. And she is just a wonderful, wonderful role model. She's also on our board for construction management, and just I think you'll be totally inspired. But just a little bit more about her. Monica is a senior manager in engineering with 16 years of experience and a well-rounded background in energy, project management, operations, engineering, maintenance, and work management. Her background includes environmental, mechanical, electrical, and civil engineering equipment, as well as 11 years of project management experience. She is a focused problem solver, constantly trying to streamline processes and generate efficiency. And I really hope she gets to tell you about some of the super cool projects that she's working on now. Interested in national and international energy startups, environmental cleanups, and nuclear, LNG, and hydrogen projects. Monica earned a Bachelor of Science in Chemical Engineering from Widener University. She will also graduate with her MBA this spring. Congratulations, Monica. And has been recognized for her volunteer work and in her professional career. So not only amazing, brilliant scholar, woman of an engineer, then she gives back to the community. As I mentioned, she serves as a member of the Widener School of Engineering Construction Management Advisory Board. And I think you're going to be totally inspired by her outstanding career. So welcome, Monica.
Thank you, Pamela. Good afternoon, everyone. My name is Monica Block. I am a Widener graduate. I was a chemical engineering student, and I'm now Senior Manager of Engineering Services for PSEG Nuclear. So today I'm going to talk to you about how to successfully transition from school into the workplace. I'm also going to talk a little bit about my circuitous journey in the workplace, different careers, different companies, and then I'm going to talk and share some lessons learned along the way, things that I have learned from the things that didn't necessarily go well for me, in hopes that you don't have to go through them the same way. And make sure you're taking notes, because there will be some quizzes along the way. And then at the end, I will open it up to some questions. So let's get started. All right, my transition into the workplace. So my junior year at Widener, I had two different job options. The first one was a rotational engineering position in the fossil fuel industry, the other an on-site systems engineering position at a nuclear plant. For me, I love the outdoors. I really enjoy high altitude mountaineering. And over my climbing career, I saw a number of glaciers shrink or disappear. And I didn't want to contribute to that issue. In fact, I wanted to reduce my impact on the climate. So for me, my lessons learned in this one is remember your why. Make sure that what you're doing aligns with what you want to do and how you want to progress and influence the world around you. So this past year, I've spent a lot of time switching positions. So as someone who applied to about 80 positions in the last year and interviewed for over 20 of those, I want to provide some guidance on how to successfully transition to the next portion of your lives. So many of you may already have positions and some of you may not. But my first piece of advice here is majority of companies, especially your Fortune 500 companies, utilize AI to screen resumes. So what does that mean for you? That means that a person may not even look at your resume. And it is absolutely crucial that you're tailoring your resume to each of the job positions you're applying for. So how do you do that? So you look at the job description. If it's a job description and a job that is of interest to you, you want to tailor your resume by pulling keywords out of that job description and including them in your resume so that when your resume goes through that artificial intelligence screening tool, it's going to pull those keywords out and say, this person is a great fit for this position. And it's going to screen you in through the interview process. The other piece here is LinkedIn. LinkedIn is a phenomenal tool for job searching. You can follow companies that you're interested in. So you have specific companies that you want to follow. You follow them on LinkedIn. You'll see kind of what they're doing. They make posts about a lot of the better companies make posts about the things that they're doing. And you can create job searches, both based on positions you're interested in, as well as geographic locations. So for me, I was looking for a senior manager position in engineering in the Philadelphia area. So I had that as a search item. And every week I was getting emailed all the positions that were meeting that requirement. In addition to that, when you're meeting people today, right? All these people are coming up asking you questions about your projects. Remember their names, look them up on LinkedIn and connect with them. One of the things I do that it really helps me is my memory is not great. So when I meet someone, I will send them a message to say, hey, it was great meeting you at the Widener Senior Project Day. So a year later, when I'm following up with them and I want to say, hey, how do I meet? I know this person. They look familiar, but I don't remember how I met them. I can go back to my messages and I can see, oh yeah, I met them at Senior Project Day. That's how I know them. And lastly, and most importantly here, make sure you send a thank you letter to your candidates, to your interviewers after you interview. I've honestly, in my hiring processes, have ruled out candidates purely because they were not thankful or they didn't follow directions. So follow directions in the interview process and make sure you're saying thank you. All right, so how did I get from chemical engineering to where I am now? So this is going to be the beginning process of my transition through that role and an overview of my career. We're going to throw in some nuclear energy facts and information along the way. So as you can see here, I did choose the nuclear industry from those two positions that I had available my junior year. I started out with PSEG Nuclear as a system engineer. So you say, what is a system engineer? And when you think, okay, classical systems engineer is the person who's reviewing computer systems. Nope, it's not like that at all. So we take the nuclear plant and we break it down into smaller groups. So you have all of your safety systems. Those are predominantly all the things that are inside of containment that affect nuclear safety. Those belong to the Nuclear Safety Systems Group. So it's called NSSS. So then you have your balance of plant side. So this is all of your steam-driven items. So this is everything that makes the power. It's taking the steam from the reactor and it's turning the generator and it's sending electric out into the grid. That's your balance of plant or BOP. So I was a BOP system engineer and responsible for 9 different chemistry systems at the nuclear plant that I worked at. So first piece of advice in this position, know the rules, requirements, and procedures around you. Obviously, nuclear plants focuses predominantly on safety. So make sure you know the procedures and you're following them in the workplace. If you're working at a union facility, I will tell you from experience, know your limitations. Story time. So there were 2 ways I got in trouble here. The first one was I was asked to come out and inspect a piece of equipment. It was a feed water heater we had opened for the outage. I worked at a union plant. I was not a union employee. So I go out to inspect the piece of equipment and it's dark inside of there. It's like, okay, I need a light. So the guy at the front of the feed water heater is a union employee. He hands me the light. He points to the outlet. Okay, so I go over, I plug it into the outlet, and I use the light and I do my inspection. I get written up because I am not a union employee and I did an electrician's job. So things like that, where you need to know who does what and don't break those rules. At this point, I really like projects. I was overseeing a number of different projects as a system engineer and enjoyed it a lot. So I moved over to an equipment reliability improvement engineer position. In this role, I was focused predominantly on improving systems and not just the systems that I previously managed, but all of the plant systems. So in this role, I was overseeing projects from the $200,000 to the $3 million range. The other piece that was crucial here, so to improve equipment reliability requires a lot of teamwork. It's for a chemistry system, I'm going out and I'm interviewing the chemistry technicians. I'm asking them, hey, what isn't working well for you in the field? How can I make your job better? And I'm looking at, okay, this piece of equipment isn't working correctly for them. How can I fix it? What's it going to take to repair that piece of equipment? And can I take that piece of equipment and look at a more holistic scale and say, okay, are there other pieces of equipment just like that have similar problems? Where if I fix all of them, I can improve the operations for that individual. The collaboration is crucial. You're going to be working with all different kinds of people. And I know you say, oh, but can't I just work by myself? Nope, you're going to have to work with people. The hardest part, I would say, during these first 5 years for me was learning how to be a professional. If I wouldn't say it to a professor, I wouldn't put it in an email. If I don't want it shared publicly with other people, don't write it down. Keep all of those things to yourself. If they're not helpful and they may be hurtful or they're not beneficial, keep them to yourself. The other big lesson learned here, don't be afraid to get dirty and ask questions. This is the best way to learn. That picture up on the top there, that is me in anti-contamination clothing inside of the Salem containment. So I got dirty quite a bit the first few years, but it was a great way to learn because I saw the inside of the components. I got to learn how they work firsthand. That picture on the right there, that was inspecting the inside of a steam vane. So that's the steam vane for the main condensers. Now we're going to transition a little bit to talk about nuclear energy industry and my site specifically. So I threw some numbers up here. So this is going to be interactive. What do they represent? Those top 3 numbers there. Any guesses? Dave, you can't answer. My husband's excluded too. Yep.
Is the far left, top left one, is that the, like the energy produced from nuclear?
Very close. Yep. So that is the nuclear power currently generates 50% of the nation's carbon-free electricity. So of all the carbon-free electricity, wind, solar, hydro, nuclear generates 50% of that for the country. All right, next one, 24/7. What do you think that one is?
24 hours, 7 days a week.
Exactly. So nuclear plants, most of the time, run at 100% power all the time. And this is really good because it allows us to, with that zero carbon energy, complement wind and solar. Because it's really windy at night. You have wind turbines spinning at night, and it's really sunny during the day. So you have solar in the daytime, but you don't have anything in the middle. So nuclear power is really good because it's base load power. We run at 100% all the time. So on the right there, you've got 92 reactors. What do we think that last number is?
The amount of total nuclear energy out of all the energy. Us.
Yep, exactly. So nuclear energy produces 20% of the electricity in the US. And uranium is incredibly powerful. Uranium-235 used in nuclear reactors is incredibly dense. So if you look at that bottom row there, a uranium fuel pellet provides as much energy as 17,000 cubic feet of natural gas, 120 gallons of oil, and 1 ton of coal in one pellet that fits between my fingers. The lifetime worth of energy for each of you. Does anybody have a soda can in here? Drink soda can. There we go. Sort of close. A normal width height soda can. The entire amount of energy you need for your entire lifetime will fit inside that can with uranium-235. All right, so now we're going to transition to me talking about kind of where I work currently. So right now I'm working at PSEG Nuclear. This is the 3rd largest nuclear generating facility in the US. It's also the only facility in the country where you can learn both technologies. So we have 2 PWRs or pressurized water reactors and 1 boiling water reactor. And these sites combined currently generate 40% of all of the electricity for New Jersey. In addition to that, they produce 85% of the state's carbon-free electricity safely and reliably. In addition, PSEG owns 49% of Constellation Energy's Peach Bottom Atomic Generating Station in Delta, Pennsylvania. And likewise, Dave would tell you that they own 49% of our reactors. So we'll get into a little bit about what I'm doing later in the presentation, but that comes into play because when I go to ask for funding, I have to ask 2 different companies for funding. All right, so career years 5 through 10, where did I go next? So at this point, I really wanted to be a senior reactor operator. I learned, how to troubleshoot systems. I learned how to upgrade plant components. And now I said, okay, I want to learn how to run a reactor. So I moved over to the Limerick Generating Station. This was closer to home for me. I grew up about 15 minutes from Limerick Generating Station. And while in this role, they began a new project to replace the plant process computer. You say, okay, I'm going to replace this computer, right? I'm going to go unplug it and I'm going to plug in the new one. Absolutely not. So the plant process computer is 22 server input-output your racks worth of equipment. It's the entire brain for the control room. So as you can imagine, it's a pretty long project, a couple years. So I got asked to be the project manager for this project and the lead responsible engineer, providing oversight for all of the engineering. So story time again. You ever get sent on a business trip and they buy you a one-way ticket? Pack extra clothes. It's gonna be a while. So I got sent on a 2-week trip to Idaho Falls to run the factory acceptance testing for our plant process computer. And I didn't come back for 5 months. So pack some extra clothes. This project required a ton of collaboration. There's numerous different clients. So you have the engineers who want the system to meet the system requirements. So they say, okay, these are the system requirements I want of the plant process computer. This is what I want it to do. Okay, I take those, I do my design, and I come back and say, okay, operators, do you like how we made this look? Do you like these screens that you're gonna be touching every day in the control room? Do you like the things that you're seeing? What do you want to look differently? Then when we, adjust the design, we create it. We build it and we do a factory acceptance test on it. So I led that factory acceptance test where I was sending operators across the country to Idaho to hang out with me and to validate that those screens work the way that they wanted to. From this role, I moved over to a role as a work week manager. So a work week manager is the person who manages all the work going on site. So 7 weeks ahead of time, you start planning all of the maintenance that's going to be done during that work week. You're looking at meeting with all the maintenance supervisors, making sure that all the mechanical work, the electrical work, the controls work is all scheduled properly. They have all the parts, everything's planned right, and you hope nothing goes wrong. Something always goes wrong. During that execution week, you have your schedule laid out, everything's perfect, and then something emergent breaks. You say, oh my gosh, what am I going to do? So you take all the items, you say, okay, what is my highest priority? What can I shift off priority so that I can now send these people that were going to be working on this pump over to fix this electrical piece of equipment that broke? And then the week after, we would take all the lessons learned and I would bundle those lessons learned together. And as a learning organization, we tried to constantly improve ourselves so that we didn't need to encounter the same issues over and over again. We want to constantly learn from the things that aren't going well. From there, I moved over to a role as maintenance supervisor. I really missed projects. I realized I really like project management. I think project management's for me and wanted to oversee projects. So I became a maintenance supervisor overseeing capital project installations. So in this role, I was overseeing crews of 10 to 30, depending on the project. So that top picture there, that is one of the emergency diesel generators. So the pistons for those are bigger than my head. They are massive. This was at Limerick Station. Limerick has 8 of them. So in a scenario, an emergency scenario where you lose offsite power, those diesels are going to start up and they're going to provide your backup power to keep the plant safety functions running. The bottom right there, that is a feed water heater level control device. So I was looking at an issue ticket that was hooked onto one of those heater level heater level instrumentation systems. The lesson learned here, don't be afraid to move around. For me, my company encouraged people to move around every 2 to 3 years. I purposely pushed myself to try new things every 2 years. This helped provide me a really good perspective of how all the different departments work together to collaborate and to be effective. It also provided me a well-rounded background of knowledge. Because now I know, okay, I know how to manage the work, I know how to run the reactor, I know how to do the engineering. What do I want to learn next? Okay, I want to learn how to install projects. So I would kind of follow where I had weaknesses and step out of my comfort zone to learn those skills that I didn't have. Continuing education. So I may be a glutton for punishment, but since graduating from Widener, I did go back and get a second Bachelor of Science in Nuclear Engineering. This was because I wanted a better understanding of the technology that I was working around every day. I wanted to make sure that the information that I was providing, I had a very good understanding of that and I could speak to it well. When I became a project manager at Limerick working on that plant process computer project, I went back and got my PMP. My PMP has been incredibly valuable in getting project management positions across the industry. It's one of those certifications that you can say, hey, I can manage a project at this plant, but I can also manage a project in IT. I can go over here and I can manage something completely different. It shows that you have transferable skills across the industries. And I highly recommend it. If you enjoy madness, project management might be for you. So later in my career journey, I realized, okay, I know how to run a nuclear plant, but I don't know how to run a business. So there's been a lot of meetings with our senior leadership team, and they're talking about return on investment and equity and financing. I'm like, what are they talking about? So I decided to go back and get my MBA. This is also during the pandemic. I had lots of free time on my hands, and now I don't have as much free time on my hands, but happy to announce in 3 weeks, I will be finishing my MBA. I'm looking forward to regaining some of that time back. You can't go to school forever. You do have to stop sometime. But due to the expedited timeline of my current project, I'm utilizing a lot more agile principles. So if you look at project management, right, you have different types of project management. You have waterfall, which is your very traditional project management, where you go, okay, project initiation, project planning, project execution, project closeout. And you go agile, okay, and you're starting to work things in parallel. You have all different types of project management, and you also have strategic management. I am now kind of shifting principles. Originally, I learned traditional project management. Now the project that I'm working on requires agile project management. So for me in the future, I'm considering getting an agile certified practitioner or a scrum master to just get better at that process of flexibility and project management in that style. In all seriousness here though, lesson learned is that take advantage of company provided programs. My second bachelor's, my PMP, and my MBA were all paid for by companies and not by me. So definitely take advantage of your company programs that are out there for you. All right, career years 10 through 12. So at this point, I moved over to Exelon Nuclear Corporate. I was a project management and maintenance outage scheduler. So in my project management scheduler role, I had 18 project managers that I was working with every day. Go over to them, ask, hey, we have these activities due this week. How are things going? So is this on track? Do I need to change things? Do I need to adjust it? Managing 26 projects simultaneously in that role. And then during refueling outages, so in the nuclear industry, you have refueling outages in the spring and the fall, because a lot of people need electricity in the winter when they're heating their houses. And in the summer, they also need electricity to cool their houses with air conditioning. So predominantly outages are in the spring and in the fall. In that role, I was the outage scheduler for all of the maintenance for all of the East Coast plants for what was Exelon, it's now Constellation. So that was 5 or 6 refueling outages a year. Quite a bit of travel, but really, really interesting. At this point, Exelon and Constellation split. So we had generation and transmission and distribution together. They then split. And now you have Constellation, that's generation, and you have Exelon, which is transmission and delivery. I said, hey, I've never worked transmission and delivery. Moving over to this other side of the company, my benefits would stay exactly the same. I'd still be at the same company, I'd just be doing something different and learning an aspect of the industry that I didn't understand. So I said, hey, let's try it. So I moved over to the Exelon electric and gas transmission and delivery side of the company. Big thing here, lesson learned is don't be afraid to change companies. For me, I found that every 5 to 7 years at the company, I would hit a salary plateau where things, I wasn't getting the salary bumps that I was expecting to see every year. So I was like, okay, if I want to make more money, I'm going to have to switch companies. And that has been very beneficial for me. Sorry, parents, gone are the days of staying at one company your entire life. Benefits are now very, very portable. Employee resource groups. So throughout my career, I've been involved in a number of employee resource groups. These are the 3 favorites that I'm involved in. The first one, North American Young Generation Nuclear. This is a professional development organization for individuals that are under 35 or have less than 10 years of experience. And these activities and participating in these groups gave me the ability to practice leadership skills in a safe place, where if I messed up, it wasn't impacting my work. It wasn't impacting a nuclear plant. And I was learning from it and able to continually grow and experience that safely. So highly recommend expanding your network by getting involved in employee resource groups. All right, career years 12 through 6. So I left nuclear, went to transmission and delivery. What am I doing now? So in this position, I started at PICO. I was working for the PICO portion of Exelon. For those of you who aren't familiar, Exelon owns 6 different operating companies. They have ComEd in Chicago. They have PICO in Philadelphia. They have Pepco Holdings it's technically housed in Newark, Delaware, but they own Atlantic City Electric, which is all of southern New Jersey. They own Delmarva Power, which is Delaware, Maryland, Virginia. And then they also own Pepco in DC. In addition to that, they own Baltimore Gas and Electric in the Baltimore area. So gas and electric all over the East Coast, plus Chicago. In this role, I started at PICO as manager of project initiation. So I had 4 project managers working for me, 6 customer liaisons, and I was overseeing any new projects that were coming through PICO. So a customer would reach out and say, hey, I want to build a new data center in the middle of the city. So that's probably not a great idea. It's going to be very challenging. But I was reviewing the risks. I was identifying what is the cost? What is the scope? What is it gonna, what risks are we gonna run into? Can I mitigate those risks? Who are the stakeholders? Who are the people that I need to be communicating with often? Getting all of that bundled together and then giving it to either an internal project manager, or if I didn't have project management resources internally, I was giving that to a project manager of choice externally and bidding it to them for that work. In addition to that, I was a principal project manager for the Bellwether District project. This is the refinery in Southwest Philly, used to be the Sunoco refinery owned by PES. Some of you may remember a very large fire a few years ago. Following that fire, part of my role was to dismantle all of the old substations, all the underground cabling, all the overhead transmission and distribution that were running through that site, with the intention of it being a life sciences manufacturing and warehouse facility. So if you look at that top picture, that's what it looked like about 4 years ago. The bottom picture is the end goal. I will tell you right now, it's about in the middle. All the equipment in the top picture is gone. It's almost back to brownfield. And the green, the picture on the bottom has not started construction yet, but we're starting to build warehouses, starting to lay out the new infrastructure there. So from that role, for me, I was looking for a little bit more life balance in my work-life balance. So I moved to a role at PHI, so still within the Exelon family, a little bit further south. So I was working in Wilmington, Delaware as manager of reliability engineering for Atlantic City Electric, Delmarva Power, and Pepco. I had 4 engineers, 3 data analysts, and our goal was to make sure that the electricity and the gas in those areas was reliable. And if it wasn't, we were doing the appropriate regulatory reporting to the different areas in those different geographic locations. What makes that complicated is, as you can imagine, right? Normally in a state, you have a public utility commission that the electric industry is regulated by. Well, when your company is in 5 different states, it gets a little complicated because each state has different requirements. From there, I moved to a role as program manager, and I was asked to oversee 2 larger projects. The first was a $92 million liquid natural gas project, replacing all the vaporization and liquefaction equipment in Wilmington, Delaware. In this role, I was responsible for the development design of the project, as well as ensuring that once the construction work started, I was responsible for construction management, safety, and execution. And my other project I also got assigned in that role was a $5 million backup distribution system for Atlantic City Electric and Delmarva Power in Carneys Point, New Jersey. So if you go back, who remembers the very first lesson learned we talked about?
Yeah.
For that?
No, you won't get there yet.
Remember your why. So for me, I realized I drifted way far away from my why. I was now working in liquid natural gas, a fossil fuel producing entity, and I felt like I was way far away from my why. So I wanted to make a change because I found myself being less passionate about what I was doing because I was not emotionally connected to the work. So at this point, I want to share the lessons learned of maintain your network. So for me, the fact that I had a network from my original time at PSEG Nuclear and I didn't burn those bridges when I left was crucial because I had someone reach out to me and say, hey, I'm looking for someone to lead our engineering for this massive project. I see you used to work at the site, you know the site very well, and we want you to come over because you have 10 years of project management experience. So maintaining that network is crucial in your future development and your career. So innovation in the workplace, we've come full circle. I started at PSEG Nuclear, I'm now back at PSEG Nuclear. And because I didn't burn any of those bridges, I maintained those connections. And now the senior manager of engineering services. So what does that look like? Well, I'm now 7 levels higher than where I started at PSEG Nuclear. I'm leading an upgrade project. So it's a $1.3 billion upgrade project to increase the power output of both Salem generating station units. Right now, we're investigating feasibility of anywhere between 3 and 10% power upgrade. And the majority of that funding is coming from the production tax credit. So if you guys are familiar with the Inflation Reduction Act, there's a number of opportunities in that Inflation Reduction Act for different companies to increase power output and do it with clean technology, things that don't produce carbon. In addition to this, at the same time, we are going after subsequent license renewals for all 3 units. So Salem Unit 1 and 2, as well as Hope Creek. What does that mean? That means we can run all 3 of those reactors for another 20 years if that's approved. So if companies want to stay technically and financially viable, it's crucial to innovate. For this project specifically on the right there, you see a number of components in that top picture. To uprate, we're looking at replacing at least half of them. And these are $1 million massive pieces of equipment. They're huge feed water heaters. We're looking at potentially an entire center line replacement of high pressure, 3 low pressure, a generator, exciter on both units. So lots and lots of equipment. But you have to innovate, because if you don't innovate, the company won't succeed. So as you can imagine, a task of this magnitude requires a lot of resources. I joined this project effort just about a month ago, and most of this year I will be building my team. So we're working on determining project scope, and I currently have 1 project manager. A lot of it I'm taking on myself, but end state, at the end of this year, I will have 25 to 30 engineers in my organization that are helping me lead this effort. So you don't need to be a nuclear engineer to work in the nuclear industry. Say, oh, I'm not a nuclear engineer. You can absolutely work in nuclear. We hire all types of engineers and we cross-train everyone. So I joined the nuclear industry as a chemical engineer, which is kind of a rarity. I would say most of the people that work at the plant are mechanical or electrical engineers, but everybody gets cross-trained exactly the same. So at the end of the first year, when you get your engineering qualifications completed, you have the same base knowledge as everybody else that works there. So this, for some of you, has been a 4 or more year journey. Today's your senior projects day, last major presentation of your undergraduate education. So I just want to say thank you, everyone, for choosing Widener. Thank you, students, for all the time and effort you've put in to get you this far. Thank you, parents, for all of your support you've provided to allow your students to succeed along the way. And as you begin the next portion of your lives, don't forget to leave with pride. Widener alums, they're all over the place, and make sure that you're reaching out and you're maintaining that network with them. At this point, I will open it up for questions.
Can you comment on any new nuclear technology that's coming up and how many years it will take?
Yeah, absolutely. And, my husband, who's in the room, works for a different nuclear energy company who's making one of these technologies, but I can speak to generally, and then I'll let him add if he wants. So there's a number of, they call the generation technology we currently have for the existing commercial nuclear fleet called generation 3 technology. So we had 1, 2, now we're on 3. What we're looking at is generation 4 technology. So we talk about innovate or die, right? If you're going to innovate, you want it to be safer. So the new reactors are much safer. A lot of them shut down by themselves without operator intervention. So the operator's not in the control room, they went on lunch break, it's going to shut down by itself. The other thing you look at is cooling, right? With climate change, you have a lot more heat in the earth, you have a lot less water. So cooling is becoming more crucial. So these newer reactors don't have as much cooling requirements. They're designed to be more passive and less actively cooled. In terms of sizing, one of the other things is if you want to go build a new nuclear plant right now, a commercial Gen 3 nuclear plant, they're in the $20 billion to $25 billion range on price tag. They are very expensive. And for a lot of companies, that's betting the farm. Like if you look at PSEG Nuclear, we're an $18 billion company. So for us to go put in a new full-size commercial nuclear plant, we're betting the company plus some on financing. So that's a big move for a lot of companies. So there's some financing involved. So for us to be successful with building large-scale nuclear facilities, we have government funding. We're going to need subsidies. We're going to need help in financing to do that. Matt, anything you want to add? This is my husband, Matt. Anything you want to add on kind of SMR? He works for Holtec, and they are developing a small modular reactor, which is a much smaller version of the large nuclear plant. They're a little bit more affordable. The dollar price tag much lower, and they can be placed in more convenient areas.
Yeah, I would just say Vogtle 3 and 4 just started up within the last 2 years. So the first nuclear plants in some 20 years. China is copy pasting them all over the place. I think a lot of the issues we have in the US is the costs, because we've only built a couple of these in the last 20, 30 years, so costs end up kind of exploding. You saw that at VC Summer and now Vogel's finally completed that. They're gonna be happy with their decision. But it's only took a lot to get there. But I think with the new nuclear technologies for the small modular reactors, middle 2030s, I think you'll see some. I think each country is looking to in different companies, different routes. You see Canada is making some pretty significant advancements. China is making some significant advancements. So I think in the 2030s, you're going to start seeing some of these advanced reactors being started up, some of the small modular reactors that can be constructed on a 5-year timeline instead of a 15-year timeline to cut down the cost, increase efficiency. So I'd say within the next 10 years or so, you're going to see a lot of these across the globe and hopefully in the United States make some progress and start contributing to that 20% and the 50% that Monica was showing earlier in her presentation.
And the other thing you start to see too is you'll see some other types of reactor designs. There's thorium reactors, molten salt reactors. So there are companies investigating and trying to do proof of concept for some of those more, I say, unusual reactor technologies.
I was actually going to ask about the thorium reactors, but I had another question about. You mentioned refueling outages. So what exactly happens during that time? Are you getting rid of old water? Are you getting rid of old control rods? What exactly is happening?
A lot is happening. So in a refueling outage, the majority of the maintenance we do, about 60% of the maintenance we do happens during a refueling outage for a multitude of different reasons. It's much easier to work on the systems when they're not spinning, when they don't have water in them, right? The other point is that when you're running a nuclear reactor, if you're inside containment, it's high radioactive area. So you don't want to work on components. You want to reduce the dose to your employees doing those things. So we shut down the reactor. Usually an outage is 30 to 40 days, depending on the company. Some are a little bit shorter. But during that time period, you're taking the reactor vessel lid off. You're pulling out the fuel rods. So we usually pull out about 1/3 of the fuel rods. We'll rearrange the other ones that are in there, and then we'll add 1/3 new ones. The ones that we take out go into a spent fuel pool, so underwater, and we let them pool in there for about 5 to 10 years. Then we take them out later on, put them in concrete, first stainless steel, then concrete storage devices outside to continue to cool down over the rest of their lifetime. But during that outage, while you also are refueling the reactor, you're working on your balance of plant equipment. You're looking at your turbine, you're looking at your generator, you're cleaning out your feed water heaters, you're looking at the bottom of your condensers to make sure that no foreign material has come from different parts of the systems that you need to clean out. So you do as much maintenance as you can during that month time period. But it's a crazy month because we'll bring in anywhere from, depends on the project, depends on the outage, like what your scope is of that outage. But a normal outage, anywhere from 600 to 3,000 employees extra, in addition to the people we have on site all the time.
Monica, I got a question. First of all, thank you for the conversation. So I think that you made probably everybody who's a graduate from one university. Now, based on what you mentioned today, it seems like nuclear is the way to go in the future. So what is holding the government in terms of try to implement all the technology where, as you mentioned, and your husband is restate that nuclear is the way to go? Who is no lobbyist in terms of, like you say, investing that money that is being spending in all the technology that and your husband know it's not going to work? So what is holding the
First off, you're welcome. It was really nice being here, and I appreciate having the opportunity to present. There's a couple things that go into the why. I feel like nuclear is the best way. Energy source is a very powerful energy source. It's very safe. It's very reliable. It runs 24/7 all the time. It's very clean. It doesn't produce, carbon emissions. So when you look at those three things, those are huge advantages. I think what's holding us back from expanding, the first thing is cost of carbon. There's no advantage to not pollute right now. Any of these companies can go out and pollute, as much as they want, and they don't get charged for it. There's no environmental fine for them releasing carbon, right? If you look at stakeholders do care. Shareholders, if it's a public company, the shareholders care about those things, but some companies don't. So cost on carbon is a big input. The other one is financing. We talked about that dollar value. They're expensive to build. So to be able to to add more to the grid, we're gonna need to find a way to lower the cost of them. Or have a system where we can get government subsidies or a way to fund them properly. I will say what we're currently doing in terms of Inflation Reduction Act with that production tax credit that's funding the project that I'm running. That's a huge advantage. That's allowing us to upgrade a lot of the existing technology across the country.
Thank you very much. Wow, it's all your white and red. Thank you so much. All right.
All right, thank you, everyone. Thank you, Monica, again. Next session is gonna begin promptly at 1:20. So 1:20 is the next session. There are some extra sandwiches for anyone that did not grab lunch, so there are some. 1:20 of that. 5 minutes. My heartbeat's finally sub 100.
You already started talking.
Yeah. Dude, I like sat there, I'm like, hey, let's go.